Today we're going to talk about slope, specifically calculating slope from a linear equation on a graph. And we're going to break this into two pieces because I don't want it to get too long. So first thing we're going to do is just cover the basics of slope, just to review that. And the first thing is, let's take a look. What is slope really? Slope is the change in the value of a dependent variable, which is generally the variable on the y-axis or vertical axis, divided by a value which is a change in the independent variable, which again generally is the variable on the x or the horizontal axis. Verbally, the way we describe this is a rate of change in y with respect to x. So how do we describe the slope mathematically? Well, one of the most common ways we do that in algebra and pre-algebra even is we talk about that as the rise over the run. In other words, how much does the line go up and then go over? The more technical way to describe that is the change in y divided by the change in x, or specifically if we have 2 points on the line, any 2 points on the line really, which are x1, y1 for point 1 and x2, y2 for the second point, we say it's y2 minus y1 divided by x2 minus x1. Now this can also be described as delta y over delta x. Delta is a Greek letter which in mathematics stands for change. You can see that in other places as well, but it works really great for slope because it's a change. It's exactly the same thing as we had over here. It's the change in y over the change in x. Okay, so where do we see slope in everyday life? Well, a handicap ramp is a great example of where we work with slope because a handicap ramp has to have a certain slope that is not too high or not too low. If it's too low, if the slope's too small, you won't get anywhere. It takes a longer ramp. But if it's too high, then it can be dangerous going down or hard to make a wheelchair go up the ramp. Okay, so another one is highway. In a highway situation like I-24 going up Monteagle Mountain, we talk about slope in terms of a percentage, 6% grade, for example, and we talk about the grade of a highway. We're talking about, for example, on a 6% grade, we'd be talking about a 6% rise or 6 feet of rise for every 100 feet of road. Now that 6% seems like a very, very small amount, but when you're actually driving it, if you're going up that grade, it takes a lot more power from your car. And if you're a big truck driving down that kind of a grade, you have to be very, very careful. So 6% in that situation is actually pretty significant. The roof of a house has a slope, and in fact they call it a slope. And if you're in the Northeast where you get a lot of snow, you want a steep slope, a steep roof slope, because you want the snow to slide off the roof rather than collecting on top. Slope of an aisle in a theater is another one where it's sloped down so that the people sitting in the back can see over the top of those that are sitting in the front. All right, so let's pause here for a moment and then we'll take a look at slope as it relates to a specific graph situation on a piece of graph paper. Okay, I'm back. Now let's take a look at this line. It's a straight line called a linear equation, and the slope of a linear equation is always constant. In other words, the amount of rise over run does not change. So it doesn't matter where we pick 2 points. We've picked 2 points here which have a position of x1, y1 here, and I'll circle that with a different color. X1, Y1, and X2, Y2. Those would be 2 points on the line, picked at convenient points on the graph. And what we would be looking at then is the rise over run. So we would say, okay, it goes up 2 units this way, and we go over 2 units to the right. Notice that both of these are positive, okay? Plus 2 and plus 4, we're going in the positive direction up, and we're going in the positive direction from left to right. So the slope here, the rise over run, would be rise over run is equal to 2 units up and 4 units over, and so this slope would be 1/2. Okay, it is a positive 1/2 because both the rise and the run are going in the positive direction. And in fact, what we can say just by looking at this graph is that if we're going uphill from left to right, that is a positive slope. Okay, so that's a positive slope going uphill from left to right. And as you can imagine, if we were going downhill from left to right, then that would be a negative slope. Okay, now what I want to do is we've looked at rise over run, but let's look at it in terms of the change in y divided by the change in x with some specific values. Okay, so let's take this same slope, and we're going to look at the values that we have here. 2, 4, 6. Hang on, I'm going to pause this and make a change. I'll be right back. Okay, I'm back. I caught a place where I'd put a wrong value in, so I wanted to change that before we continued. Okay, so what I've got here is 2 points. Again, x1, y1, and the coordinate pair here is the x value and the y value. And so you can see I'm at a -8 here. This would have been -6. So -4, -6, -8. And on the y-axis, I'm down 2 units, which is right here. And so -8 minus 2 is my x1, y1 pair. The second point I've chosen is a different one from the one we looked at before. And it is at 0 for x. Notice that this point right here is not going either left or right from the y-axis position. So the 0 is the x position, and up 2 is the y position. So x2, y2 is a point at 0, 2. So let's look at this from the standpoint of our change in y over change in x and do a quick calculation. And so we have delta y over delta x, which is the same thing as y2 minus y1 over x2 minus x1. And so what is that? X2 is at 2, and we're subtracting y2 is 2 minus minus 2. And just like everything in algebra, be very, very careful of your signs, S-I-G-N-S, because that's where a lot of algebra mistakes are made when we plug things in and we are subtracting negatives and so forth. The change in x then is 0 for x2 minus a -8, okay, which of course was the point down here, okay, that we chose. And so now let's go ahead and simplify this. So we've got 2 minus a -2, which is equal to a +4 over 0 minus a -8, which is a +8, which is equal to 1/2, which is exactly what we got when we did it using the rise over run calculation. And that's what slope is all about. Let's try one more for a linear equation. Let's look at one that has a negative slope. Here's a line with a negative slope, and we'll see what happens. So let's take a look, first of all, at our points that we're going to choose. And we can choose, let's choose this point right here. And this is back -2, -4, -6, and it's up 2, 4, 6, 8. Is that right? And let's see, that's right. So what we have here as this point is -6 on the x number line, and a +8, sorry, +8 on the y scale or number line. And down here, let's go ahead and pick this value right here for our y2. So this is x1, y1, and our x2, y2 is going to be at -2 on the x, okay, right here, -2, and we're at 2, 4. We're at +4 on the y, and this is our x2, y2, okay, and that's our coordinate pair for that. And let's do the same calculation now at this one. And so on our change in y, we're going to go from, let's see, y2 minus y1 over x2 minus x1, and that's going to equal, our y2 is 4, and we're going to subtract y1, which is -8, and minus an 8, actually not -8 but minus an 8, and then for our change in y, we are going from a -2, and we're subtracting -6, so minus a -6, okay? And so what we have here is we're going to have -4, and we got -8 plus 6, so it's actually a +4, which is a slope of -1. And that's how you have it for that slope calculation. Notice that for a negative slope, we are going downhill, left to right. Okay? And that's a quick synopsis of calculating slope. I'm going to cover one more thing in a different video about slope when each box or each scaling on the x and y is a different scale. Okay, we'll cover that on another video, and I hope this helps. And we'll also have available for you some worksheets that will be on the SBA webpage for this. Okay, we're going to stop here.